Hi guys, and welcome back to the Sun Devil Learning Lab. My name is Mrs. Lopez. If you are coming back to Sun Devil Learning Labs, welcome back. And if you are new to it and this is your first lesson, well, welcome. And let's get started. Today we're going to learn about exponents. So let me share my screen with you here real quick. And we're going to learn about exponents today. Before we do get started, I do have a joke of the day. My joke of the day today is, what is a cat's favorite color? And if you said purple is a cat's favorite color, you're right. And our materials today are a paper and pencil. So if you already have that, then we'll get started right away. Our objectives today are I can explain the difference between an expression and an equation. I can write numerical expressions involving whole number exponents, and I can evaluate numerical expressions involving whole number exponents. I'm going to repeat the objectives, and I want you to repeat them after me. I can explain the difference between an expression and an equation. I can write numerical expressions involving whole number exponents. And I can evaluate numerical expressions involving whole number exponents. Okay, so we do have some review here. So what if we added 2 plus 2 plus 2 plus 2? We know this is as repeated addition. So instead of writing 2 plus 2 plus 2 plus 2, we actually write 2 times 4 because we have 2 4 times. 1, 2, 3, 4. So if we had 2 plus 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 2, that'd be way too many numbers to count. And especially if there were more, it would take way too long to calculate, but it would also take too long to write it down. So there's actually an even faster way of doing that, and that would just be 2 times 13 because there's 13 2's right here. So writing 2 times 13 takes a lot less time than writing it out and also calculating, because then you have to do 2 plus 2 and that's equal 4, and then plus 2 and that's 6, and then plus 2 and that's 8. It's just continuous. So it would be faster and easier to just write it as 2 times 13 because there's 13 2's. This is also repeated addition. So it actually equals 26, and so it's a lot faster to write 2 times 13 to equal 26 than writing out 2 plus 2 plus 2 and so on 13 times. So what do we do now? What if we multiply 2 times 2 times 2? If we multiply it out, it might take us really fast to just multiply 4 2, but what if we had 13 2's again? That would be way too much to write out 13 times and then way too much time to calculate. Is there a faster way of writing this? Your answer should be yes. We're going to go over that today, and what is a faster way of writing 2 times 2 times 2 times 2, or 3 times 3 times 3 times 3, or 3 times 1,000, 3 going on to infinity. We're going to have a faster way of writing this. Before we do get that started, we want to go over some vocabulary. We have exponent. That's just going to tell the base how many times to repeat itself. We have a base, and that's a factor that repeats itself using multiplication. We have a factor, which is each number multiplied by a form of a product, and then exponential form that just has the base and the exponent. We have an expression versus an equation. So an expression is a math phrase that is made up of numbers and operational signs. So that includes the addition, the subtraction, multiplication, and division. And the examples are 5 plus 2 and 8 times 2. That is an expression. An equation is a math sentence that has an equal sign in it. And equations say that two things are equal to each other. So 5 plus 3 is equal to 6 plus 2. If we add that out, that's 8 on the left side and 8 on the right side. So that is an equation because they are equal to each other. 8 equals 8. Going back to our vocabulary word, exponent, it just is a number that says how many times to use that number in multiplication. So here's our base, and that is 7. Our exponent is 3. This whole thing is exponential form, so 7 3. So there are special rules to exponents. The first rule is when one number equals 1, since 1 itself always equals 1. 1 times 1 is 1. 1 times 1 times 1 times 1 is 1, because 1 times itself is always 1. So even if you have 1 times 50 or 1 raised to the 50, it's always going to equal 1. This is a special rule to exponents because, again, 1 times itself always equals 1. Okay, so we've had this first rule. Now we have our second rule. Any number to the 0 power equals 1. So when 3 is raised to the 0, it is always going to be 1. And then our third and last special rule for exponents is a number to the first power equals itself. So if you have 7 raised to the 1, or its power of 1, it is always going to be that base number 7 or the base number 6. Whatever number you have, it's always going to be that. So we have 1 raised to any power equals 1. Since 1 times itself always equals 1, you're always going to get the answer 1. So these are 3 very special rules that you need to know and understand for exponents. So 1 raised to any power is always going to be 1. Any number raised to 0 is always going to be 1. And any number raised to 1, it's always going to be that number that is in the base. So it's going to equal 7 in this example. We're going to go over some samples here. I'm going to show you, and then we're going to have you do it on your own, okay? So we have 23 raised to the 1, or the first power. What does that mean? So I want you to think about the previous slide and our rules. If you thought it is 23 raised to the power 1 is 23. So then, last one. What is 4 to the power of 3? We know that means 5. 64. That is what that means. Now, next one. 3 to the power of 2. That means we are going to multiply 3 2 times. That is not 3 times 2. It's 3 times 3 because there's 3. It's saying we want to multiply 3 by 2 itself 2 times. So 3 times 3 is 9. That is what that means. So then we have the next one. Instead of me showing you this version in exponential form, I want you to change it from this expanded form to exponential form. So that is 1 times 1 times 1 times 1 times 1 and so on. We want to know how many ones there are. So there's 1, 2, 3, 4, 5, 6, 7, 8. So that means it is 1 raised to the 8th power. That's just basically writing this form out into a more simplified form. Instead of writing it out, it's going to take way too long to calculate and way too long to write out. So you write 1 to the power of 8 because it's being multiplied by itself. We have 5 times 5. I want you to now write out what you think that exponential form is going to be. Pause the video for however long you need to write this out. If you have now 5 raised to the 2, you are correct because it's saying that 5 is multiplied by 5 2 times. There's 1, 2, 5. You have 5 raised to the 2nd power. And our last and final sample for this one is 3 times 3 times 3 times 3. We want to know how many threes are there, and that is going to be our power. So we're going to write 3 as the base, and how many threes are there? 1, 2, 3, 4. There's 4 threes, so you're going to write 3 as the base and 4 as the power because you're multiplying 3 by itself 4 times. So now we're going to have you try it yourself. So I'm going to let you pause the video, and you're going to try doing this yourself by writing it out, how many times this is, and also writing it in exponential form. How many 10s are there multiplying? Pause the video for however long you need or 10 minutes. Okay, try and get out yourself. Our first one is 3 raised to the 3. How do we write that out? You should have written out 3 times 3 times 3. And that is going to give you 27. We have 5 raised to the 3. So how much is that? That is 5 times 5 times 5. And that's going to give you 125. We have 8 raised to the 2. That means it's 8 times 8. 8 is going to be multiplied by itself 2 times, so 8 times 8 equals 64. Then our next one is 10 times 10 times 10. We want to write that in exponential form. So how do we write that in an exponential form? So that means we have 10 as the base and 3 as the exponent or the power because there's 1, 2, 3 10s. That means we're writing 10 raised to the 3. Then we have 7 raised to the 2 because there's 7 2 times and we're multiplying it by itself. So that is 7 squared. That is how you say the 2 when you're saying it in exponential form. It's 7 squared. This is also 10 cubed because 3 is cubed. but we'll learn more about that later on in our math lessons as well. And then our final one is 2 times 2 times 2 times 2 times 2. That was a lot, okay? But there is a faster way to writing that out. We do 1, 2, 3, 4, 5, 6. So we have our base 2 as our exponent. This is the thing. We're going to multiply 2 by itself 6 times. 2 times 2 times 2 times 2 times 2 times 2. So now we're going to go over our objectives again. I can explain the difference between an expression and an equation. Give yourself some time, maybe talk to a person next to you or the person that you're doing this lesson with, but explain to them what the difference is between an expression and an equation. Hint, an expression only deals with like addition, multiplication, subtraction, and division, and the equation is the equal sign. Okay? Then we can write numerical expressions involving whole number exponents. So we've already done that. We've done that by writing the base of 3 and the exponent of 2. You're writing those out already. And evaluating those numerical expressions. Using that same example of the 3 as the base and the 2 as the exponent, you multiplied them out and you also got your answer. So you're evaluating those numerical expressions as well. We have some games that you can play with as well. We have Math Playground, and these are math games for exponents. You'll get those on your guides as well for the lesson. And I hope you had a wonderful time during this lesson, and I hope it was very helpful for you and you have a better understanding on exponents. If not, rewatch the lesson and try doing more examples yourself and or play some of those games that are provided for you as well. See you guys next time.